So first, a little bit about myself. I'm a professor of computer science in programming languages and systems, working in very foundational aspects, but also applications, and worked in various areas. So we've worked with contract technology and blockchain technology broadly for many years. So the first thing I wanted to do is actually give an introduction of what I mean, at least, and I hope actually we'll get to an agreement as to blockchain and how it is perceived. So first of all, as a topic, blockchain is widely spread out on the Gartner hype cycle. So it's from anywhere from being in the disappointment phase when it comes to so-called ICOs, to like general blockchain, to actually very smart contracts or blockchain supply chain. As you can see, it's a very topical thing. And remember, it's a hype cycle in the sense that there's a lot of focus on it and an exploration of the potential. And it has actually matured over the last years. So having said that, let's think about, when people say blockchain, I have to say that the first thing is like I try to have a conversation to understand what people mean by blockchain, because different kinds of senses and perspectives and interpretations of it. So I'm a little bit facetious in the following, but let's look at this. So the orthodox view, and this is where the term comes from, is from Bitcoin and Ethereum. Okay, so you will find actually lots of people who will say like blockchain is basically referencing to systems like Bitcoin and Ethereum. So these are two distributed systems with anonymous participants, highly replicated, and they have a cryptocurrency, and that's the key thing about them. Now, there's a more loose, interpretation of it, loose in the sense of a more general one. So in practice, very often you might find, well, okay, this is maybe a picture of what, you shouldn't be able to see this even, as this like a replicated state machine, and there's kind of like pointers to each other. And this is what you may have seen when people talk about blockchain and Bitcoin in particular, but also Ethereum as a platform for executing programs on this network of computers. So a more popular view is that I found very often is the following one. It's used in the sense of it's got something to do with things like Merkle trees, and sometimes people don't really know what that means. So it's something about cryptographic hashing, and then terms like wallets pop up, and that's terminology might be a little bit misleading. Wallets are nothing else but digital managed personal containers of private keys. So it always sounds like there is some stuff in there in the wallets, but there's actually, the stuff is not in the wallets. There's only an access code to get to the real stuff. I mean, whatever it is, cryptocurrencies. And there's of course a network of computers, and it has something to do with cryptocurrencies. That's rather diffuse. So I'd rather present a modern view of it. So so sometimes this is called distributed ledger technology view. So just to emphasize that it's not just the classical systems that were built on and where the name comes from, but also modern systems that do these things. So it's basically not any kind of fixed system, but it's a computer system that consists of a network of computers. So I don't know if you can see my pointer. I hope you can. So it's a peer-to-peer computer network. So it's network computers. So the most obvious computer network we have in the world, it's so obvious nowadays that people forget it's actually a peer-to-peer computer network, is the internet. Okay, so the internet has a dynamic number of computer nodes on it. Dynamic means like, nobody's getting permission or giving centrally permission to be on the network. You can join it, and it's peer-to-peer. The systems, the individual nodes as they're called, they communicate with each other, but there's some properties you want. So think of it as like, it's a peer-to-peer network. It's computers. They can, the edges mean they can send messages to each other. But they do the thing is like, the key thing is like, even though it's a network, to a user of it, even to a programmer, it looks like it's a single reliable virtual computer. So virtual means like when you program it, it's as if you were programming one big computer, sometimes called a world computer. Okay, you might want to be old-fashioned, say it's like a mainframe. Okay, but that's not a modern terminology. So the key thing is like it's doing two things. Namely, it's this whole network looks like a single computer, yet that single computer is not run by a single company or person, or it's still run by all the members that run the individual nodes, and they're independent of each other. So a way of saying this is that it has decentralized governance. So there's many, it could be arbitrarily many, sometimes anonymous, sometimes they're a consortium of participants, they know each other and you have to join the club. And these are called permission systems. But it's not just a single provider, okay? It's not just a single cloud provider. It's not a single agent that then has privileged access to the data on it. So it behaves like a single, so imagine this is like, you know, a single computer here, and this is your computer communicating with this virtual computer, which doesn't really exist in reality. In reality, it's complicated underlying stuff, you know, consensus protocols you may have heard of and so on, that make this network look like it were a single computer. So there's two key aspects that you know, a blockchain brought to it. This is actually one aspect of blockchain. It's like it's a way of recording in a tamper-proof fashion digitally signed real-world events. So what that means is data. Somebody makes some data. Usually these things originally were like I want to transfer money to Anas, for example. So I will sign it off and say, okay, it gets logged, and then it has happened on that one. But it could be other data, like, for example, I have delivered 5 kilograms of coffee to to Anas. Okay, so it's think of it, that's the same thing, and I'll sign it off, and then it will be recorded, and it's tamper-proof in the sense that somebody from later on can check that this was actually recorded and was not changed. So the important part is that it wasn't changed. And our modern interpretation is like, since these can be real world events, you can associate evidence with it. So not just my digital signature, but maybe a picture or DNA or X-ray data that support that this digital recorded event actually reflects a real world event. That's very important for the applications we have in the area of food, where we don't just deal with money as a digital asset, but with real things. So the second thing is securely managing economic resources. It's very abstract. What that really means is we have things and money, and securely managing means that they're not duplicated. So we can, in this virtual computer, so remember, it's everybody's running their own computer, and still it is not possible for anybody to do stuff that you would usually do, is like copy data. The copying will be recognized as something that's illegal. So it guarantees that the data stored in it represent resources like coffee or money. They are securely stored and transferred, but transfer means that they disappear from the ownership of one party, and they're actually then the sole ownership of the other party. So they're not duplicated. And this includes things like, you know, that is usually not done in blockchain applications, but that we've done here is transportation of goods from one location to the other. They can't be in two locations. And transformation of economic resources. That's rather new in the sense that we can guarantee that things that have been produced cannot be, they must consume resources. Otherwise, you know, you can't take the same resources and produce two different things from it, okay? So this would be a way of forging real resources. So, and by highlighting goods here, you got to think here as goods as food, commodity or non-commodity items. They can be highly specialized things, individual items that can track at the bean level if you want to, or they can be fungible, which means like, okay, I'm tracking 5 kilograms of coffee. So, but it's the 5 kilograms I have. So what this provides, and this is the central slide, so I'm basically spending a lot of time on that, sorry about that. It provides a consistent, non-repeatable history across all actors. In other words, there's lots of people involved. They're independent. Should they trust each other? Okay. So what this does, it provides a trustworthy platform, a technological platform for saying like, yes, the recorded data cannot be changed by anybody. And the economic resources are preserved. So you cannot produce 2 liters of virgin pressed olive oil out of the same number of original grapes, which has been done in quite a bit of time when we do resource tracking. So the platform guarantees it's not possible, okay? So that kind of cheating or error is not possible. So, and then, it could, depending on what you do, this is very often, there's very different. It could either guarantee high levels of privacy or no level of privacy, okay? So there's different ways of looking at this, okay? So the key thing is that the last part means that there's a symmetric access and control. So everybody who participates knows there's not a single party who's got a lot more control over the data, the processes. They cannot, stop your process and keep their process running and so on. It's really an equitable way of having these things running. Okay, there's no single power. So this is very important. Sometimes if you have three competitors collaborating, they will usually not agree on one of them running the database server, okay, because that gives them an advantage. So then there's secure tracking and tracing, which means like, the events are recorded, and from those we can put together, we can stickle together, and I'll give an indication of that, and Lars will say more about this, how this is done for coffee. And no forging and double spending possible. So basically the platform makes it impossible to do at least that sheet, okay? You can still steal digitally. So all of a sudden you say like, I own this, but in reality you don't. But you can't duplicate the resources. So there is a couple of current favorites that are used widely. So the ones that are heavily used, these are so-called non-permissioned ones, and very, very expensive to run because they have to be, civil attack resistant, which means that they have to work even though people can give themselves a million identities. And it's very important to remember when people say anonymous is not, the most important part of anonymous is like, I can be any one of a million identities out there, okay? So if you only have one identity on Bitcoin, I don't know, you're a strange person, okay? So permissioned means that no, there is an access control, you get basically identified, and you have much, much more classical and much more energy efficient protocols. So energy consumption of these blockchain systems is way lower than the ones above. So, and there's build your own because you can show that there's no ideal one for all users. So why use this? So that's why, supply chain networks. So we have, producers, transporters, halfway, manufacturers. So why should they be interested in blockchain at all as a technology? Well, let's look at the preferences. So you have usually many independent cooperating actors. They cooperate, they deliver to each other, but it's not like, one of them gives all the data to the next one. I mean, usually they prefer not to do that. So that suggests there's an interest in decentralization of having such a computer network. So nobody's really given, like privileged control over it. The practice is that right now we're seeing that a single actor actually controls the supply chain. So basically, if you're a dominant party, you might be interested in doing this, but maybe the other party is not so interested in having all the data. I don't know, a big automotive manufacturer wants to get all the data from not only their suppliers, but the suppliers' suppliers and so on. Or if you don't have that, you have no effective way of what I would call deep tracking. So not just, where do I get my stuff from my supplier? I know that, of course, because, but if somebody finds a fault in the product I've produced, where are the original components coming from? Okay. Well, I can only go to my supplier. And then if I don't have deep access to all the data, it actually turns out to be surprisingly difficult in practice to find the causes, even though we have a lot of data available nowadays. So consensus and relevant. So in practice, very often it turns out you and I actually exchange things, but we record things slightly differently. Anas has received something from me. I've recorded that. Anas records it, but after a while, we find out you have recorded it slightly different in your database than me. So there is a lot of reconciliation inconsistencies. In practice, it's actually stunning how much work and manual processing there is in reconciliating events or data. So this is a single source of truth that's sometimes called, and the trustworthy auditing, of course, I don't know, you look at my database, I could have sort of like lost data or finagled it a little bit. So, that's greatly helped by tamper-proof recording. And many of the things like, auditing could be things like, checking where the food comes from. As I mentioned before, you want to make sure that people can't easily forge certificates or, make sure that it looks like it's a nicely, sustainably grown product while it actually isn't. So blockchain for coffee, just wrapping up now. So blockchain for coffee, we've developed a modeling framework. That's an extended framework from 80s, 90s, zero. So the key thing is like, we're working with different kinds of resources. Those could be money, or in this case, different kinds of coffee. The events, it's an event-based model. It says like, well, you can transfer, these resources like ownership, possession, you can transport them and you can transform them. And the transformation, it sounds abstract. It means like it's production, right? Some parchment coffee disappears and then some green coffee pops up. Think about it this way: this is producing, this is milling. It produces green coffee from parchment, from coffee and parchment. And packing, unpacking is basically the same thing. It's just like, I have a whole identified bag of coffee. I can even pack it together into a truckload and then unpack it again, and I can trace this back and forth. Okay. There's also observations. For example, you observe that a bag of anything or a truck has been observed. You scan it and you register that. There's tests of coffee quality tests, cupping. There's actor authentication that says, like, an actor is actually certified to, for example, issue certificates to a farmer. So this is the general framework, and we've applied it to the coffee tracking. But I hope you'll get an idea that this should be applicable and is applicable to tracking and tracing other things. The information is to make sure that we have a reliable way of tracking coffee from cherry to cup, you might say, from the original farmer to the final cup that you'll drink. So, and as I mentioned, the evidence could be anything at all that's associated with this, and it's tamper-proof. An implementation, decentralized platform for a coffee supply chain. We've worked this out with our project partners. So you can probably see this very nicely, but this is a web app. So it's a running web app. You can run it on your, on this thing, whatever you have, and see actually where, a product, maybe a cup of coffee, where it comes from. It could come from different sources because it's been blended and so on, and where it's been. Status, we have a database-based implementation, also one where Ethereum has been used as a backend. And we're preparing a pilot test where this is the digital platform that shadows, you could say, the actual tracking and tracing of some real coffee that is being shipped, will be shipped from Colombia in this case. And we're planning a web app demonstration, a public event to show this is applicable to the broad public. So I want to say at the end, thanks to the COVI Foundation that made this research possible, and of course to our project partners at Chalmers, at COVI, who are leading the managing project. At ITU, Peter Larsenkach, who was an important, and you will see Lars later on actually, and our colleagues at both DIKU Computer Science Department, at the Geology and Geoscience Department. And there's some contact information. Thanks.